Welcome back, folks. In today's class, I'll talk about a new topic that is force. Now, first of all, what is force? In simple words, if I have to tell you force is equal to mass times acceleration. It's the product of mass and acceleration. But there are different types of force. We'll get into that later on. So if you see the force, this formula, there is a vector on top. So it is a vector quantity. Vector quantity. Now, when we talk about the force, we will apply the same rules as we applied to all those quantities which were vector quantities like velocity and displacement. So what we said about the displacement, d net is equal to d1 plus d2 plus d3 and so on and so forth. Another formula for d net was, d means the net displacement. So d net was d final minus d initial. So what was the difference between these two formulas? The difference was if you are trying to measure the displacement between 2 points, then we will use this formula. If we are trying to sum up all the different displacement which had happened in a given situation, then we will use this formula. For example, that let's say you start from this point, you move in the east direction, then you move back in the west direction, then you move in the east direction, then you move back to this position. So you can add up all these displacements based on the direction in which they are moving. So you can find the net displacement. Same, these two formulas we can apply to the force. So force is equal to F1 plus F2 plus so and so forth. Another formula, as I said, F is equal to mass times acceleration. And this is for net average force, net average force. This one is also net average force. All right. So we need to remember this thing because as I said earlier in the beginning that there can be different types of forces. So now I'm going to come to that point. So if this is an object which is placed, oops, let me redraw the diagram. So if this object is placed on a ground and then I'm trying to pull it in the forward direction. So I'm applying certain force. Let's say the applied force is 200 Newton. And then because of the resistance caused by the ground, that force of friction, I will call it as 100 Newton. I'll take just a random number. Now, I can clearly see this applied force is bigger than the force of friction. So the object will move towards the right hand side. Now, can I write applied force F applied equal to F net? No, I cannot write this equation because there is a frictional force involved also. Friction net force will be equal to sum of all these forces, this force and this force. There are only two forces in this case, so I'll take these two. Force applied minus force of friction. Now force of friction is 100 Newton, force applied is 200 Newton, and F net will come out to be 100 Newton, right? The units of force is Newton. And other units we can say that if I try to make the units from mass and acceleration, then it will be mass units is kg and acceleration is meters per second square. So Newton is equal to kg meters per second square. It's only that the Newton was the scientist who discovered the force for the first time around. So we use the units as the Newton too. So you can use kg meters per second square or the Newton too. Now coming back to this question, this was, as I said, F net we figured out from here. Now only we can compare this net force which we got here, that is equal to mass times acceleration. If I would have started like this, F applied equal to mass times acceleration, I can never write it like this. This would have been wrong. Okay, applied force can never be equal to mass times acceleration. Only the net force is equal to mass times acceleration. All right. So you cannot even write the frictional force also equal to mass times acceleration. So hopefully that's clear to you guys. So sometimes why I'm emphasizing on this one, because sometimes students end up making a mistake. They end up writing, hey, there is only applied force. And let's say if I give the condition that no friction, and 200 Newton is the force applied in the forward direction. So in the book, they will see that, okay, applied force equal to ma. I wanted to find the acceleration. So this will be, let's say the mass is 10 kgs, and then 200 equal to 10 times acceleration, dividing both sides by 10, cancels out. Acceleration comes out to be 20 uh, meters per second square. This is correct, but this is not complete. This is where the confusion starts. So what's happening is, because there is no friction, the actual equation was force applied equal to, not force applied, force net is equal to force applied plus minus force of friction. Why I use the plus minus? Because the frictional force can be in any direction depending upon where the force applied is. If the force applied is towards the right, then the frictional force will always be opposite to that. If the frictional force is in the right direction, then the applied force will be in the left direction. All right, so this is the formula, and in this formula, if I write it as force applied, now no friction means this becomes 0, equal to F net. Now force applied is equal to mass times acceleration. That's why I got it equal to this, because there was no friction involved. If there was friction involved, I cannot just directly write that force applied equal to mass times acceleration. So hopefully with this detailed view, you can see what's net formula is and how to use these formulas. All right, and then when we are on into the earth space, we will always talk about the frictional force, especially on the ground. So for example, if this is an object, I am trying to pull it in the forward direction with 100 Newton, and obviously because it's placed on the ground, so there will always be a frictional force, and frictional force will try to oppose the motion, and which will be, let's say the frictional force comes out to be 30 Newton. So you can easily calculate the net force from here, 100 minus 30, which is equal to 70 Newton. So these were some of the basics in the horizontal direction. Now we're going to talk about certain basics in the vertical direction. So if the object, this is an object, you are trying to lift it up. So for example, if I talk about the elevator also, elevator is a lift in which people travel from one place to another, from ground to the top floor, I can say that too. So if this object is moving vertically up or down, then what kind of different forces which will act on this elevator or on this uh, given situation? So F net, I can write it as, let's say, what are the forces acting on this? One is there is an applied force which is trying to pull it in the upward direction. So force applied, and then there is also a downward force, that is force due to gravity. All right. So acceleration due to gravity always acts in the downward direction, come what may. So minus Fg. Why I use the minus in this case? Because acceleration due to gravity, as I said, will act in the downward direction. The applied force in this case, let's assume it as 100 Newton, and the gravitational force in the downward direction is 30 Newton. So that will provide me the net force in this case also, F net equal to 100 minus 30, which will come out to be 70 Newton. So F net. So if I compare both the formulas, the previous formula, which was F net equal to force applied minus or plus minus force of friction, depending upon where the applied force is. So this formula we applied on the horizontal when the object is moving on a horizontal plane, and when the object is moving on a vertical plane, force of friction will be replaced with force due to gravity, and this will always be negative, not a positive, because force due to gravity always acts in the downward direction, which is equal to F net. All right. So these are certain basics which I wanted to talk about before start jumping into some math problems on this topic. So let's talk about a math problem. So this is an object which I'm trying to pull it in the upward direction. And the mass of this object is, let's say, 20 kgs. All right. And I wanted to find out what is the acceleration with which this object will move in upward direction if the applied force is equal to, let's say I would call it as 400 Newton. I'm just taking some random numbers right now. So force applied minus Fg, which is equal to net force, F net. Now, applied force is equal to 400 as given to me, and it is up, so I'll consider it as positive. 400 minus Fg. Gravitational force is not given to me. This is 20 kgs. Now, just for the sake of question, I will take the G value as 10 because I don't have the calculator with me right now. So I'll put it as 10 meters per second, but G value is 9.81 meters per second. All right. So I'm going to place this number 20 times 9.81. Now, caution here. I haven't used the negative sign this one. Usually what students do is they end up placing a negative sign here. Okay, G value, because it's always X in the downward direction, so I'll place this negative here. If you end up placing this negative down here, there is a negative here also. Then both will add up and it's going to become positive. Then your answer will be wrong. Because gravity is acting in the downward direction, thus force due to gravity will also act in the downward direction. That's why I've taken the sign of force as negative down here. I cannot take the same sign twice. So either you keep it with the gravity or with the force. Okay. So I kept it with the force because I know that if the gravity is acting in downward direction, force will also act in the downward direction. I don't need to put the sign twice. All right, so now I'm going to do the calculation here. As I said, I'm going to use the number as 10. So the calculation will be 400 minus 200. So the net force will be equal to 200 Newton. This is the net force which is acting onto this object. Now this net force is equal to what? This is equal to mass times acceleration. Why I've written this? Because I wanted to find out the acceleration with which the object is moving. So mass times acceleration is equal to 200 Newton. Mass of the object is 20 kgs. Acceleration equal to 200. Dividing both sides by 20. Dividing other side by 20 also. So acceleration will come out to be, that will be 10 meters per second square. So hopefully this gives you an idea about what force is. I'll see you with the multiple problems in another video. Till then, have a good day.